Okay. Good evening, dear students. Sorry for the delay. There is some network issue here. That's why it is delayed. Okay. Today's session is important concepts for GATE and ESE regarding design of concrete structures. The subject is the design of concrete structures. And today's session is important concepts for GATE and ESE. See, my dear, it is very difficult to judge from which area the question will be framed. Okay, anyway, I can say that from this area there will be more and more chances to ask the question like that. Don't think that only that area is important, the rest of the areas are unimportant. I am telling probability. Okay, right. Weightage of the subject, my dear, in GATE exam 6 to 8 marks, and in ESE weightage of this subject is 15 to 20 questions, right? In terms of number of questions I have given here. Coming to the syllabus, see, in GATE exam, construction materials given separately, which is not given under concrete structures. Okay. Under construction materials, they have given structural steel, composition, material properties, and behavior. My dear, the questions will not focus on this. On this, they are not going to focus much. They will focus more and more from this concrete and concrete related materials like constituents, mixed design, short-term and long-term properties. Mainly they will focus on tests from cement and from concrete. Mainly they focus on laboratory tests. Okay. Coming to the next one. Better I can write here because here concrete structures will be there, so better I can write at the top. Okay, if you don't mind. Yes. From this, you can focus on cement as well as on concrete. Laboratory tests. There is a chance to ask one question from the materials, my dear. So it will take less time. It will take less time. If you spend around 4 to 5 hours, you will get one question, no doubt. Not required more than that, my dear. Time 4 to 5 hours is more than sufficient for this syllabus. Okay. Maybe they will ask a question from water, that too permissible limits on solids. This is another area where we can expect one question. Okay, right. This is about construction materials. Coming to the next, concrete structures. My dear, working stress and limit state design concepts. I think you too know that designs they don't ask in exam. Design related concepts they will ask. Design related are dimensions of the member, maybe a beam, maybe a slab, maybe a column, maybe a footing, right? Dimensions, there is a chance to ask dimensions. What is the area of the column? What is the area of the footing, or what is the size of the footing, what is the size of the beam, or what is the depth of the beam? This type of questions you will expect. And another one related to design is area of steel. How much area of steel required in beam? How much area of steel required in column? How much area of steel required in footing? Like that. Next one, design of beams. Yes, not only from working stress method, even from limit state method, questions will ask, right? From both the methods, right? Mostly they will focus on limit state method. Simultaneously, don't ignore working stress method. there is a chance to ask question from working stress method also. Coming to the slabs, then columns. Footings is not given in the syllabus, but footing is nothing but inverted slab. So you will expect questions from footings chapter also. Even they have not mentioned in the syllabus shear, but they have given here design of beams. My dear, beams subjected to flexor, beams subjected to flexor, even beams subjected to shear, beams subjected to torsion. They have not mentioned here flexor, shear, torsion, simply given design of beams. So question may be asked based on flexor concept or based on shear concept or based on torsion concept. Based on flexor, we have seen singly reinforced beams, doubly reinforced beams, flanged beams. Coming to the shear, shear separately we have discussed, even torsion also we have discussed separately, right? Okay. Next one, bond and development length. Bond and development length. Bond and development length. Then pre-stressed concrete. Up to here only it is RCC. Next one, my dear, pre-stressed concrete beams. Simply given pre-stressed concrete beams or design of pre-stressed concrete beams, like that it is given in the syllabus. My dear, under pre-stressed concrete, fundamentals will be there, analysis will be there, losses will be there, then deflection will be there, right? Regularly questions are asking from these two areas, analysis as well as losses. It doesn't mean that they don't ask this year from this chapter and this chapter. We can't predict, but focus more on these two chapters, right? These two chapters are very easy if you understand, my dear, the concept, background concept. If you understand, then it will be very easy to score, right? You will expect 1 to 2 questions from pre-stressed concrete. In worst case, 1 question. In best case, they will give 2 questions. They don't give more than 2 questions from pre-stressed concrete in GATE exam. Okay, right. Coming to the next one, syllabus for ESE. Here, design of concrete and masonry structures. But take light regarding masonry structures. Very rarely questions will ask from this. So better you can leave it. It is up to you. My suggestion, better leave it. You can give time, my dear, same time you can give it for other topic or other chapter or other subject. It will be beneficial. Next, here what is the syllabus regarding this? Limit state design for bending, shear, axial compression and combined forces. Here very clearly mentioned bending, shear, axial compression, combined forces, like that. Okay. Then design of beams, slabs, lintels, foundations, retaining walls, tanks, staircases, up to here RCC. Up to here RCC. Okay. After that it is pre-stressed concrete, my dear. Up to here it is pre-stressed concrete. Once again it is RCC. Again it is RCC. Then it is masonry structures. Okay. Better you can give least priority to this, or you can give the priority at the end, because it is not a chapter, it is a subject. Hardly 1 question will ask from this, but you need to spend more time for this, right? Instead of this, better you can give the time for other subject or other chapters. It will be beneficial. Okay, right. Here regarding pre-stressed concrete, my dear, they have given principles of pre-stressed concrete design, including materials and methods. Same here also, my dear. Analysis and losses, deflections, they focus more. Rest of the part will be there, miscellaneous part, designs. Rarely they will ask questions. So focus mainly on the 3 chapters, analysis chapter, losses, then design from pre-stressed concrete. Okay. good number of questions will ask from pre-stressed concrete in ESE. In GATE exam, 1 or 2 maximum, that's it. But in ESE, good number of questions will ask even from pre-stressed concrete. Okay, right. So don't ignore it. Coming to the topics, sir, here working stress method is not there. Is it required to cover working stress method? Yes. Last before year, if you observe once, 5 questions given as it is, whatever I discussed in class, same questions also, my dear, in the same pattern they asked. They changed the data, numbers they changed, questions pattern also same, right? From working stress method, 5 questions, 1, 2, 3, 4, 5, right? From working stress method. Only from one method they have asked 5 questions, that too from one chapter. Singly reinforced beams under working stress method. Okay, come on. Coming to the next, lintels. It is a very small chapter. From this chapter, there is a chance to ask, my dear, 2 questions. One is, what will be the maximum bending moment? Maximum bending moment. After that, there is a chance to ask, when arch action is possible. One condition is there. Capital H is greater than or equals to 1.25 times small h. Then arch action is possible. Means the distribution of load from masonry wall above the lintel, how it will transfer. Is it transferred the whole weight above the lintel or only triangular loading? That depends on the height of the masonry, and also opening is there. Na? Based on that opening, we can calculate the height of triangle, height of imaginary triangle we can find out based on the width of the opening, because from the width of the opening we can find out the effective span. Okay, right. This is the arch. See, this height we want, that is small h. This height depends upon the effective span. Effective span depends upon the width of the opening. Okay, right. Mostly these 2 questions, there is a chance to ask WL by 8 plus WL square upon 8. This is a maximum bending moment. Arch action is possible if h is greater than or equals to 1.25 times small h. Okay, right? Fine. Coming to the next one, tanks. No doubt, questions will ask rarely from retaining walls. Last year, I think they have not focused on these topics, but this year, you can expect 1 question from the 3 chapters. We don't know from which chapter they will ask. From these 3 chapters, my dear, 1 question will ask. Hardly for this chapter, you need to spend time 1 hour. Sufficient. For this chapter, where is the tanks? Tanks also, hardly 1 hour. Not required beyond that. For prelims I am talking. Retaining walls 1 hour. 3 hours, if you spend, you will get 1 question. Easily you can answer 1 question, right? Okay, coming to the next one, my dear, it is common every time they will ask questions from basic chapters like singly reinforced beams. 1 to 2 questions compulsory from that chapter. After that, singly reinforced beams, my dear, question will be there from shear chapter. After that, question will be there from slabs chapter. After that, question will be there from columns chapter. Here you need to focus more. Okay, it doesn't mean that you need to leave it to other topics. You need to cover other topics also, but you can ignore this one. Choice is yours. If you want to cover, yes, you can cover, right? If you are thorough with these topics and you find that still you have a time, better you can go through this one also, that one and this one. Okay, na? Right? Fine. My dear, some of the model questions I would like to discuss here. Time, you know, only 1 hour we have. Within 1 hour, it is highly impossible to cover more and more number of questions. Instead of discussing, my dear, hurry-burryly more number of questions, I decided to discuss, my dear, so cool and less number of questions and varieties of questions I am going to discuss here. Okay, right, come on. At the end, I will give time for you for queries. Okay, if you want to ask anything, you can ask at the end. Okay, right. Okay, what is there in this subject? You know very well. Already in the last session also I told. Once again, I would like to tell you here, it will not take much time. IS codal specifications, definitions, then concepts. In GATE exam as well as in ESE exam, questions mostly focus on concepts. Mostly focus on concepts. After that, they will go for definitions and codal specifications, right? So give more and more priority to understand the concepts. To answer the questions, you must have clarity in concepts. Okay, my dear? Coming to the next, yeah. IS codal specifications. See, these are the codal specifications. Yes, there is a chance to ask minimum cover, maybe in beam, maybe in slab, maybe in column, or maybe in footing, or maybe in pre-stressed concrete. There is a chance to ask a question in ESE, not in GATE. In ESE, there is a chance to ask a question. Coming to the, here I have mentioned for beams, slabs, columns, and footings, right? Coming to the next one, minimum area of steel. Yes, there is a chance to ask a question from minimum area of steel for beams, slabs, columns, footings, my dear. Definitely, you will expect in GATE as well as in ESE. In both exams, you will expect the question from minimum area of steel for beams, slabs, columns, and footings. Coming to the next one, maximum area of steel. Mostly, you can expect maximum area of steel in ESE than GATE. Then minimum diameter, maximum diameter, yes, in ESE only. This is, my dear, ESE. ESE. This one, both ESE and GATE. What happened to this? Okay, this side I can write. This is, you can find in ESE. Yeah, this one, both GATE and ESE. Chance is there, GATE and ESE. Then this one, ESE, clearly in ESE, there is a chance to ask a question from maximum area of steel for beams, slabs, columns, footings, right? Then minimum diameter, maximum diameter, yes, in ESE only, in GATE, chances are very less. Minimum and maximum spacing, my dear, yes, there is chance in GATE as well as in ESE. Then assumptions, my dear, very, very important. Assumptions, very, very important. We have seen assumptions in flexor as well as assumptions in compression, even assumptions in working stress method. At 3 places only we have seen. Maybe in statement type questions you may expect, either in GATE or in ESE. Coming to the effective span of beams, this time you will expect question from effective span of beams, my dear, maybe in ESE. In ESE you may expect. Then side face reinforcement, it is important for both, for GATE as well as for ESE. Deep beams, my dear, it is important for ESE. When do you say simply supported beam as a deep beam? Similarly, when do you say a continuous beam as a deep beam? Like that. Then minimum number of bars, ESE only. Minimum eccentricity, it is for both GATE and ESE. Minimum edge thickness of footing, ESE. Then minimum depth of foundation, both GATE and ESE. Right? Okay, na? Fine. Coming to the next one, definitions. Effective depth. My dear, in GATE, they will convert this definition into a numerical question, right? Definition as it is, you may expect in ESE, but this definition is converted into a numerical question in GATE exam. Singly reinforced beam, maybe ESE point of view, theoretical definition only important. Doubly reinforced beam, same ESE only. Lever arm, yes, gate as well as ESE. Maybe they will ask a definition or they will ask, my dear, a numerical question. Lever arm is nothing but distance between compressive force and tensile force. In working stress method, you will get, my dear, D minus XC upon 3 or XA upon 3. It depends on the type of the section. Whereas in limit state method, D minus 0.42 XU or 0.42 XU max. It depends upon the type of section. Next, characteristic load, important for gate as well as for ESC. Characteristic strength, yes, important for gate as well as for ESC. Then shear span, then what is column, pedestal, slenderness ratio, effective length of column and aspect ratio. Yes, there is a chance to ask in ESC. Okay. Coming to the next one, concepts. Type of sections, my dear, whether it is a balanced section or under reinforced section or over reinforced section, maybe a theoretical question or a numerical question you will expect. Coming to the next one, need of doubly reinforced beams. 100% it is a theoretical question. You can expect both in gate as well as in ESC. Critical depth of neutral axis, my dear, numerical question. If you understand concept, then easily you can answer. Compressive force, yes. Tensile force, lever arm, my dear, regarding the stress block parameters, yes, you will expect. Actual depth of neutral axis, moment of resistance, percentage of tension steel, stress block parameters in limit state method, strain in compression steel, effective width of flange, nominal shear stress, in uniform depth of beams as well as in uniformly varying depth of beams. How is the nominal shear stress? Yes, you will expect. Coming to the next, torsion steel in slabs. Yes, load carrying capacity of column. It is a famous concept for gate exam, right? Maybe alternate years they are asking. Load carrying capacity of circular column, load carrying capacity of rectangular column, load carrying capacity of tied column, load carrying capacity of helically reinforced column, or what is the diameter of the column required. These are the common questions for gate. Then critical section in footings. Yes, these are the concepts. I have given only here, my dear, up to here it is, what is that, RCC. Next, coming to the pre-stressed concrete. Need of high strength concrete and steel. Analysis of pre-stressed concrete members. Estimation of losses. Deflection of pre-stressed concrete members. Yes, these are the concepts from this subject. So you need to understand these concepts. Okay. Okay, fine. Coming to the questions, we'll see. We'll work out here questions. Okay. Right. First question is that a singly reinforced rectangular section of 200 mm wide, my dear, width of the beam given 200 mm and 500 mm effective depth. Yes, effective depth given 500 mm. Reinforced with 3 bars of 20 mm diameter related to area of steel. Some information given here. Used Fe 415 steel bars. Okay. That means we will get Fy value. Fy equals to 415. And given that M20 grade concrete, that means FCK value we can take it. It is 20 Newton per mm square or 20 megapascal. Take modular ratio is 13. Okay. The given beam is a, wow, my dear, options. Balanced section, B, under reinforced section, C, over reinforced section, D, effective section. Okay. They are asking type of the section. My dear, here they have not mentioned that this question is from limit state method or this question is from working stress method, but they have given take modular ratio is 13. From this, you can understand this question is from working stress method. Okay. My dear, how do you decide or judge whether the given section is A balanced section or under reinforced section or over reinforced section. My dear, in two ways we can judge. One way is that comparing XA and XC, actual neutral axis depth and critical neutral axis depth. By comparing these two, we can decide which section is it. If XA equal to XC, it is, my dear, balanced section. If XA less than XC, under reinforced section. XA greater than XC, over reinforced section, like that. There is another way to decide type of section by comparing PT and PTCR. By comparing these two also we can judge. Which is easy? Which is easy? My dear, XC is a K times D. Finding K value is not a problem in GATE exam by using virtual calculator, right? Yes, we can find out. Coming to the actual depth of neutral axis, my dear, what is the actual depth of neutral axis for a singly reinforced beam under working stress method? It is BXA square upon 2 equal to M times AST into D minus XA. You will get a quadratic equation. To solve quadratic equation, if scientific calculator is available, then easy. Within less time we can finish it. Otherwise, we have to write the formula, my dear, to find out the roots. Minus B plus R minus root over B square minus 4AC upon 2A. My dear, it is taking too much time. So, I don't recommend this way to decide the answer. Better you can follow this. You can save the time, right? Easily you will judge. Okay, how? See, my dear, okay, here since it is a working stress method, instead of writing Fy and Fck, I can write down the permissible stresses, okay? If it is limit state method, we can write Fy equals to 415, Fck equals to 20, like that. But here I can write in another way. For this one, sigma st value 230 Newton per mm square, or you can say 230 megapascal, okay? For M20 grade concrete, sigma CBC value is 7 Newton per mm square. 7 Newton per mm square, okay? Na? Fine. My dear, they have given a modular ratio M. Let us make use of it. Fine. First of all, I would like to find out percentage of tension steel in the given beam section. What is the percentage of steel section given? PT equal to 100 AST upon BD. Okay? Right. 100 AST. How many number of bars given? 3 bars given. What is the diameter given? 20 mm. So, area of steel you can determine like this. 100 into 3 into pi by 4 into 20 square. Is it okay? Fine. Next one, BD, where B is 200 mm, where B is 200 mm. What is the D here? 500. Okay, let us simplify this. Simplify this. If you don't mind, can you tell me the value? I can write down. Just a minute. If you calculated already, you tell me, otherwise I can calculate. Anybody did calculate it? Please respond. Yeah. Any value given here? Students, given by? Here, how do you get these messages? 10 charts will be there. It is blocked, huh? live chat. Anyone in the class? 0.94. Akhil, very good Akhil. 0.94. Yeah, right now. Yeah, first I thought that please, I didn't see you. Akhil Das, 0.942. Very good, Mr. Akhil. What about remaining students? Please respond quickly. Okay, then I want PTCR. My dear, PTCR, it is 50 times sigma CBC upon sigma ST into K. So we want a K value here. We want K value. My dear, K is the neutral axis depth constant, that is M sigma CBC upon M sigma CBC. Wait a minute. Yeah. M sigma CBC plus sigma ST. Now, M value given 13, sigma CBC 7 upon 13 into 7 plus sigma ST value 230. May I know this one? Ramanjaneyulu given 0.98. Which answer is correct? Akhil, tell me this value is 0.94 or 0.98? Ramanjaneyulu given 0.98, but you have given 0.94. Difference is there. What about the other students? Come on, my dear. Please participate and tell me the value. Okay, meanwhile, few students, come on, do this. You are taking time. Okay, I will also calculate. Tell me if it is wrong. If it is wrong. 0.942, Shivashankar. Okay. Okay, Mr. Shiva. 0.942 is correct. Ramanjaneyulu, please check your value. Okay. This value, I think, who is Ganesh? 0.28. Ganesh is getting 0.28. Yeah. 0.28. Yes, Akhil, 0.28. Okay. Now I will substitute here 50 into what will be the sigma CBC here? 7. And what is sigma ST here? 230. And what is K value here? 0.28. May I know this value? If you don't mind, may I know this value? 50 into 7 upon 230 into 0.28. How much you are getting? Quick, quick, quick. I think 0 point only you will get it. What is that value? I want to know. Come on. Anybody? 50 into 7 upon 230 into 0.28. How much is it? I will calculate meanwhile. 50 into 7 into 0.28 upon 230. I am getting 0.426. 0.426 I am getting. Okay, leave it. Here, let us compare PT and PTCR. Here, my dear, PT is more than PTCR. PT is more than PTCR. Therefore, it is over-reinforced section. Therefore, it is over-reinforced section. Okay, na? Right? So, option C is correct. Option C is correct. I hope you are comfortable with this. Right? Then moving to next question. A simply supported RC beam carries UDL and is referred to as beam A. Okay? Similar beam is pre-stressed and carries the same UDL as the beam A. This beam is referred to as the beam B. The mid-span deflection of beam A will be options given more than that of beam B, less than that of beam B, C same as that of beam B, D generally less but sometimes more depending upon the magnitude of UDL. My dear, see here, it is the simply supported beam. It is subjected to uniformly distributed load. Okay. Now, same simply supported beam, same size only, same load also, but it is pre-stressed concrete beam. It is not RCC, it is pre-stressed concrete beam. Now, which beam will have more deflection or the same deflection? This is made of RCC, this is made of pre-stressed concrete. You know, my dear, this load is balanced by this pre-stressing cable. This load balanced by this pre-stressing cable. So, here the mid-span deflection of beam A will be more compared to this one. Here deflection will be more because under the load it is going to deflect. But here previously we have done, my dear, applied pre-stress na, due to that member is bent into hogging curvature, right? It will balance the load, that's why deflection will be less for pre-stressed concrete. Deflection will be more for RCC beam. So, the mid-span deflection of beam A will be more than that of beam B. Okay, na? Right. Next one. Yeah. Another beautiful question. For a pre-tensioned rectangular plank, the uplift at the center on release of wires from anchors due to pre-tensioning only, force is the P and eccentricity be the E. Eccentricity is missing, E will be. Here, my dear, they are asking uplift. Uplift. We have to understand first, where do we keep the tenon? Suppose if you keep the tenon exactly at center, then beam will not lift up, will not bend down. Okay, it will not bend up, it will not bend down. It will not deflect up, it will not deflect down. Where if you keep the tenon exactly at center. Suppose if you keep the tenon at the top, my dear, the beam will deflect down, but we want uplift. So keep the tenon at bottom. Next, which shape of cable? They have not mentioned in the question, but it is given that pre-tensioned. In pre-tensioning method, we have to provide straight tenons only. Because of the straight tenons, the beam will lift up. Okay, the bending moment diagram corresponding to the given force system is, bending moment diagram will be like this. Here moment will come, here moment will come. This is the bending moment diagram. What will be the moment? P into E. Where do you want deflection? At mid-span. Give the hatched portion till mid-span. From here to here, distance is L by 2. What is centroid? My dear, L by 4. Deflection can be determined in different ways, in different methods, but here most suitable method is Morse method. According to Morse theorem 2, deflection equal to AX bar upon EI. My dear, area of this hatching portion is PE into L by 2. This is the area. X bar, centroid of the bending moment diagram of hatched portion is L by 4 upon EI. So, if I simplify, I will get PEL square upon 8EI. The deflection is upward. So, PEL square upon 8EI is the correct one. Okay? Right? Fine. Next question. See here. a singly reinforced rectangular section of a 250 mm wide, here given 250 mm wide and 500 mm effective depth is 500 mm, reinforced with the 4 bars of 20 mm diameter. So related to area of tension steel, some information given here. And it is a mild steel bars. They have used mild steel bars. Mild steel grade is Fe250. Mild steel grade is Fe250. The concrete used is M20. So FCK equal to 20 megapascal. The ultimate moment of resistance of the beam in kilonewton meter is, in this question also they didn't mention use working stress method or use limit state method, but they used one word ultimate. That ultimate we can take it only in limit state method. Okay, right, ultimate moment of resistance. My dear, to find out ultimate moment of resistance, we have to decide first which section is given. They have not mentioned it is a balanced section, it is under reinforced section, it is a over reinforced section, like that. Okay, to find out moment of resistance, we must know which type of section is given. Okay, to decide the type of section, we will compare actual neutral axis depth and limiting depth of neutral axis. Okay, na? Right, this is one way. Another way is PT and PT limit. But to find out moment of resistance, we need either XU or XU max. That's why I am going to compare XU and XU max. Here quadratic equations will not come, so we can use XU and XU max for deciding the type of the section. Okay, so first step, find out limiting depth of neutral axis XU max. For which grade of steel? For Fe250 grade steel. It is 0.53 D. 0.53 D value, effective depth is 500. May I know this? 0.53 into 0.53 into D is 500. 265, right? Check it. If it is mistake, tell me. Then actual depth of neutral axis required, just equate compressive force to tensile force, that is 0.36. FCK I will write down directly here. FCK is 20. B is 250 into XU equal to 0.87. Fy, grade of steel Fe250, so Fy is equals to 250. AST, it is 4 bars of 20 mm dia, 4 into pi by 4 into 20 square. What is the value of XU you are getting? May I know this XU? Mm, 0.87 Fy AST, 4 into 314.159 divided by 0.36 into FCK into B. B is 250. .36 into FCK into B. Yeah, I am getting very high value. 0.87, check it. Fy into AST. Yeah. Here actually divided by 151.8. 151.84. Let us say 8 mm. Now compare XU and XU max. XU is less than XU max, correct? Therefore, it is under reinforced section. Okay. My dear, find the moment of resistance for under reinforced section. MR equals to T into Z. That is 0.87 Fy AST into D minus 0.42 XU. Substitute the values, you will get the answer. 0.87 Fy 250 AST. How many numbers? 4 numbers. 4 into pi by 4 into 20 square. Into D is 500 minus 0.42 into XU is 151.8. If you simplify, you will get the answer. You will get in Newton mm. You will get in Newton mm, my dear. Then convert into kilonewton meter. Okay, because we need answer in kilonewton meter. Be careful. If it is numerical answer type question, my dear, within the brackets, what is the units and how many decimal places they are asking, let us cross check twice. Okay, right, because sometimes students will get the correct answer, but they don't check what is given within the brackets. That's why they are getting unnecessarily negative marking. For this, negative marking is not there. They are losing the marks. Okay, right. Next one, next question. Okay, how much you are getting? 119, Ganesh, 119. Okay, already one student is getting, so I can write down here it is 119 kilonewton meter. If it is wrong, please change it. Okay, na? Right. Moving to next question. A RC axially loaded column has the effective length 3.2 meter. Minimum eccentricity is more than 20 mm. For the column, both ends held in position, but one end is not restrained against rotation. The width of the column is a beautiful question. This question is not asked so far either in GATE or in ESE. This question is not asked so far either in GATE or in ESE. Beautiful question. They are asking what is the width of the column. Right. See, my dear, they have mentioned that it is axially loaded column. Some hints will be there. That hints we need to catch. Okay. Right. For axially loaded column, one condition will be there. What is the condition? E minimum must be less than or equal to, in worst case equal to, okay, 0.05 times least lateral dimension of the column. Right now, effective length given, but to find out minimum eccentricity, actually we want, okay, let me write here. Minimum eccentricity is more than 20 mm. First of all, what is the minimum eccentricity? E minimum equal to unsupported length of column upon 500 plus lateral dimension upon 30 or 20 mm or 20 mm, whichever is maximum. Whichever is maximum. Okay, na? Whichever is maximum. They are telling very clearly minimum eccentricity is more than 20 mm. Here actually 20 mm is there. Here one more is there. So in these two, whichever is maximum, that value we can take. Correct, na? Yes or no? Right. So we need to take right now this one because eccentricity is more than 20 mm. Okay, fine. We will take that. But we need unsupported length because here given effective length of the column. Fine. One more condition, axially loaded column. For axially loaded column, my dear, E minimum less than or equal to 0.05 times least lateral dimension of the column. Let us take in worst case equal to. Take it equal to. That one E minimum, na? So I can substitute here E minimum as this value will be, let us take equal to right now. This value will be B by 20. Okay, na? So I can write down here, this is B by 20 equal to L upon 500 plus B upon 30. Okay. Now send B by 30 to left hand side, you will get B by 20 minus B by 30 equal to L upon 500. Okay. So this value you will get it 30 minus 20, 10, 10 by 600. So 60. B by 60. B by 60 equal to L upon 500. Okay. My dear, I want B. B equals to 60 upon 500 times L. But we need L right now. My dear, here given effective length is 3.2 meter. One condition given for the column, both ends held in position. This is the column, both ends held in position. But one end is not restrained against rotation. Okay, this is the end, it is not restrained. So what is the effective length for this condition? For this condition, effective length is equals to 0.8 L. What do you want from this? I want unsupported length. That is equals to L upon 0.8. What is the L given in this question? 3.2. 3.2 upon 0.8. So how much it is? You'll get 4. You'll get 4 meters. Okay? Either 4 meter or you can write 4000 mm. Fine. My dear, this is 60 upon 500 into 4000. 4000 na? 2 zeros gone. 5 ones are 5 eights are. So you'll get 480 mm. Beautiful question. Beautiful question. They are asking to find out width of the column. But here they mentioned, my dear, two things. It is axially loaded column, number 1. Number 2, eccentricity is more than 20 mm. From that, actually these two we need to take. In these two, whichever is maximum, that is adopted. Correct na? But here we are going to take this because the value should be more than 20 mm. They have mentioned in the question itself. Beautiful question. It is 480 mm is the answer. Okay na? Right. And one more thing, you must know how to convert effective length to unsupported length. Okay? Right. Oh, wait. Here given that a rectangular combined footing supports two columns, column A and column B, carries load 1000 kilonewton and 800 kilonewton respectively. The soil pressure below the footing is uniform. Okay. The value of X in meter is dash. My dear, it is the combined footing. This is supporting to two columns, name AB, and they are asking to find out the value of X. They have given center to center distance, they have given width of the footing, they have given length of the footing. My dear, here one condition given, the soil pressure is uniform. When it is possible? It is possible when CG of footing and CG of column loads coincided. Okay. So first you need to find here CG either with respect to this column A or with respect to column B. Right now I will take with respect to column B. Okay. First CG of footing. CG of footing. Total 5 meters. It is a rectangular footing. That's why L by 2. 2.5 meters. From where it is 2.5 meters? From the edge. From here to here. From here to here, 2.5 meters. Okay, na? From here to here, 2.5 meters. CG of the footing we are getting. Next, say it is X1 bar. Next, CG of column loads. CG of column loads. Say X2 bar, which is equal to, my dear, you can take a column load WB into starting point 0 plus WA into, we need to take from this one, na? Starting point is this. Wait, with respect to this point, right? With respect to this point, column B is a W, starting point, into 0 plus WA into this distance. Okay? About this point. WA into distance is how much? 3 meters upon column load WB plus WA. WB plus WA. Okay, na? Right. Fine. Now, what is here WA column load? 1000. 1000 into distance 3 meters. Center to center distance. W 1000 plus 800. How much is it? It is 3000 upon 1800. My dear, it is 3000 upon 1800. 1.666 like that I am getting. Let us take 1.67 meter. Now the question is, from where to where? It is 1.67 meters. My dear, from the CG of the column. WB is 0, na? So you can take it from here. You can take it from here. Okay? Starting point here, na? WA into this distance. WB into this. Okay? Fine. 1.67. Yeah. Actually, we are taking from here to here. This is 1.67. I am sorry. It is 1.67 meters. It is a remaining distance. 3 minus 1.67. 3 minus 1.67. 1.33 meter. This is 1.33 meter. Right? We want X value here. How do you get X? See, X plus 1.33, X plus 1.33 equal to X plus 1.33 equal to 2.5 meter. 2.5 meter. These two equal, na? CG of column load and CG of footing coincided. Right. So what is the value of X? 2.5 minus 1.33, 1.17 meter. So X value from here to here is 1.17 meter. Okay, na? Right? Good question. Okay. Moving to next. Yeah. My dear, this is the last question. Actually, there is a time constraint. Okay. Fine. This is the last question. Come on. A rectangular beam of width B is 230 mm. Effective depth is 450 mm. It is the effective depth. Is reinforced with 4 bars of 12 mm diameter. The grade of concrete is M20. So FCK equals to 20. And grade of steel is Fe 500, so Fy value equals to 500. Given that for M20 grade concrete, the ultimate shear strength tau UC equals to 0.36 Newton per mm square. For steel percentage, P is equals to 0.25 and tau UC equals to 0.48 and P is equals to 0.5. For factored shear force of 90 kilonewton, the diameter in mm of Fe 500 steel, 2-legged stirrups to be used at spacing of 375 mm. I have modified here. Small changes I have done it. Okay. Already it is a previous year gate question. Just I have modified the data. Here, if I modify the data, my dear, the solution will also be changed. Right. First of all, we need to find out nominal shear stress tau V. Tau V equals to Vu upon Bd. My dear, Vu given here 90 kilonewton, 90 into 10 cubed upon Bd. B is 230 mm, D is, what is the D value? 450. May I know this value? How much it is? My dear, 90 into 10 cubed, okay, upon 230 into 450, okay. 0.869, let us say 0.87 Newton per mm square. Next, I want tau C, but it is not given directly, it is given indirectly. So find out percentage of tension steel PT, that is 100 AST upon BD. 100 AST. AST is how many numbers? 4 numbers. Diameter 12. So pi by 4 into 12 square. Upon BD 230 into 450. How much it is? 100 into 113 into 4 divided by 230 into 450. I am getting 0.436, let us say 0.437, 437 percentage, but actually 0.25 tau C is 0.48. For 0.5, no, this is a tau C for 0.25, this is the tau C for 0.5 percentage, but actually we want for 0.437. My dear, even if I take 0.5% also, tau C value will be less only, correct? But anyway, we want tau C value, so let us find tau C. Find tau C here. Tau C or tau UC equal to 0.36 plus 0.48 minus 0.36 upon 0.5 minus 0.25 into 437 minus 0.25. After simplification, you will get something, right? My dear, 0.48 minus 0.36 into 0.437 are 0.437 minus 0.25 divided by 0.25 plus 0.36, 0.4497, let us say 0.45 Newton per mm square. Okay, my dear, compare tau V and tau C, tau UC. Tau V greater than tau C, not safe. If it is not safe, then what to do? If it is not safe, let us design for shear. Means we need to find out the diameter based on design shear reinforcement. Design for shear. Yes, move to next slide. Actually, here we will find out VUS. VUS equal to VU minus tau C into BD. You will get this. After getting this, then write down VUS is equals to 0.87 Fy ASV into D upon SV. Everything is known. VUS is known, 0.87. Fy is known. Fy is 500. ASV, it is a two-legged pi by 4 into diameter square. Except this, everything is known. D upon SV. See here, SV given 375 SV. Effective depth given, my dear, 450, and it is given Fy value 500. Everything is known. VUS you calculate and substitute, you will get diameter. The question is, what is the diameter required? You will get the diameter. Okay, now I think you will understand, dear students, it is not possible to cover all the concepts in 1 hour, right? Anyway, I have taken some beautiful questions, and also I told you in which areas you need to focus more. I hope it is useful for you, right? If you have still doubt, my dear, you can ask once, okay? One question, Akhil, tau UC same as tau C max? No, these two are not same. Tau C different, tau C max different. Tau C is the design shear strength. Tau C max is the maximum allowable shear stress in concrete. These two are not same, right? Then Okay, anything? Anything? Okay, my dear. Okay, thanks for your nice cooperation. Right, come on. If you have doubts, anything related to subject, sir, where can we get such kind of questions? Actually, a few questions I have taken up, Mr. Who is that person? Mr. Shahida. Mr. Shahid, you will not get actually from books. Just some of the questions I have modified actually, right? Because in that model there is a chance to ask the questions, and some questions myself framed. There are few questions myself framed, and a few questions I have taken from previous year GATE and ESE, no doubt about that. Right? Is it clear? Mr. Shahid, and one student Tom. Yes, you are not putting even your name also. Okay. Is this similar to ACE online coaching? Acha. Maybe you are not attended to any class. I think so. First refer my notes, then you can ask. Right. Okay, my dear. Carry on. Students, dear students, is it audible? I hope it is audible. Where can I get your notes, sir, please? Actually, Mr. Shahid, you will get it just in fresh chart is there, na? Fresh chart. From there you can get my notes. Okay, right. Next, who is that another student, Tom? Is this similar to ACE online coaching? Is it worth taking ACE online coaching? If you take coaching, then you will understand whether it is worthy or not. Right? If you know ABCDs, then you will understand words, you will understand even sentences. If you don't know ABCD also, then better don't take it.